Alrighty, guys, so let us have a look at of adding and subtracting fractions. Again, please don't worry about load shedding and all the rest of it. Everything was recorded. Oh, excuse me. Alrighty, so let's do this. What we want to be able to do in this lesson is we want to be able to add and subtract our fractions. Now, when we add and subtract fractions, I've said here a golden rule, but there's something very, very important that we need to remember when we start adding and subtracting our fractions. And that is essentially that in order to compare fractions, i.e. in order to be able to add and subtract fractions, we need to find an LCD. Now, LCD, remember, stands for lowest common denominator. And to find your LCD, you sort of need to go back to your multiples. So denominator. You need to go back and think, what is the smallest number? All of the denominators that you're working with, sorry guys, all of the denominators that you're working with can divide into. So I'm going to try put that there here for us. So this is the smallest number the denominators can divide into. I can't solve, so that's also not useful. And this is why we often think about our multiples, because multiples are all the numbers our values can divide into. Alrighty, now sometimes you will have a common denominator already done for you and you don't need to worry about it. But most of the time, you're going to have to find it. And so being able to do that is very, very important. So there's some examples that I've given you here, and this is more just so you can see what needs to happen when adding or subtracting. Now remember, a fraction represents part of a whole. So here we've got 5 sevens. So there are my 5 blocks shaded in. And then we've got 4 sevens, so my 4 blocks shaded in, right? I'm adding those two together. Now, the reason I'm able to draw this beautiful picture, each of them with 7 blocks, is because my denominators are the same. They have a lowest common denominator. And only once my denominators are the same can I add them together. And so I take these 5 blocks, that was a weird looking bracket, and these 4 blocks, and I would add 4 and 5. And that's where I'm getting that 9 from. It's still over the same denominator because I still have 7 blocks that I'm working with, or 7 parts to my whole that I'm working with. And so in order for me to be able to add, I have to have an LCD. The same thing happens when I subtract. So if I have a look on the other side, and I've got 5 over 7, so they're my 5 shaded in blocks. I can't highlight very well tonight, but anywho. Minus 3 over 7, so minus my 3 shaded in blocks. I can do the same thing. I've got 5 blocks, and I want to take away 3 blocks. So if I scratch out 3 blocks, I'm left with 2 blocks. Hence, my answer of 2 over 7. But again, I could only do all of this because my denominators were the same. I was able to do this comparison, or I was able to do this operation because my denominators are the same. So very, very, very important when working with fractions, and only when you are trying to add or subtract do we need to have an LCD. So very importantly, it's only when you add and subtract fractions. We're going to talk about multiplying and dividing fractions, but you only need an LCD when you are adding or subtracting. Alrighty, so I'll wait here in case you want to take a screenshot, but let's have a look at some examples of how we actually go and add and subtract fractions. If anyone has a question at this point, you can raise your hand. Otherwise, we're going to jump straight into our examples.
Are we ready? Are we ready, my people? Let's go on this full force. Let's go. I see Uratile is there ready. Thunder, are you just like, chilling there? And I'm talking to you because your video is on, so I'm gonna pick on you because I'm not sure what you're doing there. But please find, I hope that's not a picture. Please, no, it's not. But Tandolwetsu, please find yourself a seat somewhere so that we can enjoy all together, okay? Okay, Tando, thank you. You need to find a seat. Otherwise, I'm gonna tell anyone who's an adult that they must watch you out, and you don't want me to do that. So, yeah.
Alrighty, guys. So let's have a look at some examples going on here. So our first example we have is 2/3 plus 1/6. So the very first thing I check for, or the first thing I do, is I find my LCD. Now remember, your LCD is the smallest number all your denominators can divide into. So first things first is I look at what my denominators are. My denominators here, and remember denominators, the bottom number, are 3 and 6. So on the chat for me, I don't want any hands. On the chat, write down for me what is the smallest number that 6 and 3 can divide into. So basically, what is your LCD here? The smallest number that they can both divide into. Okay, guys.
Let's go, my people.
Let's see what this actually means. When I'm saying the smallest number that they can divide into, I want to have a number that I can say divided by 6 with no remainder. And I want that very same number that I can divide by 3 with no remainder. That is essentially what an LCD is. So in order to do that, I need to look at all the multiples of 3 and 6. So let's start with 6. I've got 6, 12, 18, 24, and I can keep going. If I go to my multiples of 3, I've got 3, 6, 9, 12, 15, and I can keep going. So what I now want to do is I want to find the smallest number that is common to both. So if I have a look, 6 is my smallest number common to both of them. It is the smallest number that 6 and 3 can divide into. So now if I go back here to my block, if I say 6 divided, that was a weird looking 6, I'm sorry. Let's try that again. If I said 6 divided by 6, I get 1, no remainder. If I say 6 divided by 3, I get 2, no remainder. So I've got no remainders here when I divide my denominators into my LCD. And that's essentially what I'm looking for. I'm not looking for factors, I'm looking for multiples. And if you get stuck, write out your multiples of your denominator and see which one is the smallest. So here, my LCD we now know is 6. Now what that means is I want to go and make these denominators the same. So my second step is make denominators the same. And in order to do this, we will use multiplication. So we need to ask ourselves, what should I multiply my denominators by to make it my LCD? So if I start with my denominator of 3, what should I multiply 3 by in order to make it 6? Well, I know if I say 2 times 3, I get 6. Good, Ortile. And so what I do to the bottom, I must do to the top. It's a fraction. I need to keep it meaning the same thing. My second fraction is already a denominator of 6, so I don't need to fiddle with it. I leave it exactly as it is. And so now what I go and do is I multiply my fraction. So 2 times 2 in the numerator is 4, and 2 times 3 in the denominator we know is 6. And I need to add 1/6. So now I've got a situation where my denominators are the same, and I can now go and work with that. So once I've made my denominators the same, my third step is to simplify. And when I say simplify, I mean go and add or subtract. And so in this case, I'm adding my values. Now remember, the whole point of an LCD is so that you can compare the two, and essentially so that you can get one fraction. So what we actually have is the numerators being added together, so 4 plus 1, all over 6. And we know that 4 plus 1 is 5. And so my sum here is 5/6. All right, so very, very important is that you find an LCD. And remember, guys, LCD is the smallest number that both or all of your denominators can divide into. And once we have our LCD, we can make the denominators all the same, and we can then go and add or subtract. Right, so I'll wait here for you to take a screenshot. If anyone has any questions, now's the time to raise your hand.
Yeah, my people, did we get this? Because the first one, the teacher Sam explained, y'all were quiet. And I was expecting y'all to actually get this one. So let's get on the roll, my people. All right, Tile, I hope you understood. So everyone who has understood, please give me a thumbs up on the chat so teacher Sam can see, and we're all going to be happy. If you did understand this example, please give thumbs up. If you didn't understand, give this one, okay? So teacher Sam can have another example to explain to you, okay? Okay, Sizani, we see you, we love you. Fiona, I see you giving a thumbs up. Let's go. So Sizani, please raise your hand at this moment. Mivuyo, I see you. Sizani, please raise your hand so you can ask a question. Orlando, I see you. We're waiting for Sizani. Sizani, we don't have much time. We love you, but you know, we are
Guys,
rolling.
and remember, so like Yolanda says, like, ask questions. The chat is there. Put your questions on the chat if you need to. Also, when you ask a question, please don't just say, I don't understand, re-explain everything. Tell me what you don't understand. I can't sit and re-explain the same thing over and over again. I need to know what is confusing you. So if the multiplication by 2 is confusing you, tell me that. Because, yeah, like Yolanda says, we don't have all night. And if you are going to say repeat everything, I'm just going to tell you to rewatch the video.
Yes. So I see a couple of you. I don't know why Sizani put your hand down. Sizani, put your hand up. Let's go. Ritumedzi also put your hand up. I'm picking on you guys. Samu, put your hand up so we can answer your question. Let's go, my people. Guys, let's go. If I don't see your hands in 5 seconds, we're gonna move on. So we don't want to leave you behind because teacher Sam and I love you. And of course, we're going to do more examples, so you'll catch on. There we go. Thank you, Shoshetelo. Thank you. Thank you. Thank you for coming to the rescue. Ask Shoshetelo. Let's tell Teacher Sam what's the problem. You can unmute on your side. Well done, and you are brave. Yes, Sam. Samu, sorry. My bad. So, Dr. Della, I have actually unmuted you on my side. There's a pop-up that you need to click on it so you can ask. But while we wait for you, I will unmute Samu. Samu, please talk to us. Unmute yourself and ask us questions. We are here for questions. Some of you can ask questions on the chat. You're more than welcome. Yes, Samu.
Ma'am, what I don't understand is that, ma'am, what I do, I take 2 and plus it by 1, and it goes to 3. But I don't know how we got here when we say 2 times 2 and 2 times 3, ma'am.
Okay, so remember, you can't add 2 plus 1 unless you have a common denominator. So you can only add once your denominators are the same. So only once I've made both denominators 6 can I then do the addition. And in order for me to make this denominator 3, so this original denominator 3 is 6, I have to times it by 2. And so that is why I'm multiplying by 2, so that my denominators are the same. And only once my denominators are the same can I do the addition. We can't add our fractions until we have a common denominator. So we can't say 2 plus 1 because the denominators are the same. When my denominators are the same, I can then go and add them. Okay, so I hope that makes sense. We are going to do more examples, guys, so don't stress yourselves. We are going to do more. But so important, you have to have this LCD. Without an LCD, you can't add these fractions. All right. Just quickly, Tloletelo, you said, what about the work that you said we were going to do today? This is the work that we're doing today. We're doing fractions. So I'm not too sure which work you are referring to, but obviously if you let us know in the chat, we can see what you're talking about. If it is the brain break, then remember we'll do that in the brain break, because there was a brain break that we had to try and finish off. All right, guys, I'm assuming everyone's got their screenshots while I was explaining. So let's have a look at another example and see how we can keep practicing these additional fractions.
And well done, Samu. Well done, Samu, for asking. That's brave. I'm loving it. Well done.
Alrighty, guys. So again, we want an LCD here. So let's use the trick that we now know. Let's list all of our multiples of 3. So 3, 6, 9, 12, 15. We only need to list like the first couple, and then we can see how we go. And if we look at the multiples of 4, we've got 4, 8, 12, 16, and so on. So quickly in the chat, what do you guys think the LCD is? Which is the smallest one that is common to both of them? Type it in the chat for me. So Kutle, well done. Laura, well done. And Bali, nice guys, we're getting it. That's awesome.
Woo!
So we can see that the smallest number that's common to both is 12.
Well
And so
done, guys.
That means that my LCD here is 12. So now I have to make both of these denominators 12. So I start with my first fraction. If I times the 3 by 4, I'll get 12. But what I do to the bottom, I have to do to the top. I can't only do it to the denominator. I have to keep my fraction equivalent. It has to mean the same thing. Then I look at my second fraction. Now the second fraction also needs to change its denominator. And I know that if I say 4 times 3, I'm going to get 12. But I can't just times the denominator, I must times the numerator as well. And so now I can go and write my fractions with the same denominators. So for the first fraction, 4 times 2 is 8 over 12. And in my second fraction, I've got plus 1 times 3 is 3 over 12. And now those denominators are the same. That is what I want. I can only start adding where my denominators are the same. And so now what I can do is I can write everything over 12, and I can say 8 plus 3. And 8 plus 3, I think someone put it on the chat already, is 11 all over my denominator of 12. Nice, Ortile. So 11 over 12 is my sum here. Tingle, that's who put it in on the chat. Well done. Mavoyo, well done. So guys, once we have our LCD, that is when we can add. Because what we have done is we've created that common denominator. We've created a situation where we can now compare our fractions and start adding or subtracting away from them. But before I do that, my denominators have to be the same. So I got my LCD. The second step that I followed was to make my denominators the same, and then I simplified.
Well done, my people. I see, Tingo, you were too fast for me. I was like, what? Tingo was saying 11 over 12, and I was like, Tingo, we're finding the denominator. It can't be 11 over 12. It can't be 11 over 12. So Tingo, I get you. Next time, when you give an answer, just say B, and then you say, equals to this number. Then I will know that is an answer. Because sometimes, teachers them asks step by step. Then I get confused. Like, what? But it's 12. How can you say that? So well done, my people. Hopefully we got 100% for that, and take screenshots.
Yeah, guys, screenshots. Again, if you have questions, now's the time to raise your hand. Hopefully now that we've done a second example, those of you that weren't feeling all too comfortable with this, it now makes a little bit more sense. Okay, I'm just waiting another second or two. Nigel, do you have a question for us?
Yeah.
Yes.
I don't understand there when you say 4 times 3. Ne? What about we make 4 times 4 times into? It can give us 12. Our denominator is our LCD is 12. Ne? But how can we change the into the 1 over 4 there?
Okay, so remember, in order for me to make 4 12, so in order for me to get 12, I have to times it by 3, because 4 times 3 is 12. So that's how I get that denominator of 12. But then I also have to say 1 times 3. So that's why I then have the 3 in my numerator.
Okay.
Does that make more sense?
Yeah.
Okay, good.
Well done, Nigel, and thank you for asking. Remember, if you don't understand, you are more than welcome to still ask and put it on the chat so we can try and best explain to the best of our ability so that you can understand, okay? Because I heard a little bit of like, ish. So Remember, don't be scared. Just won't get tired to explain to you. As long as you know where you are getting confused, she'll definitely explain to you until you understand. Okay. I see Samu's hand also. Samu, you can ask.
Ma'am, what I don't understand is that every time with times we multiply, is it always going to be 3 or it's going to change?
It's going to change. It depends on what the LCD is.
Okay.
Okay. So guys, that's a very important question. We don't always times by 3. It very much depends on what our lowest common denominator is and what we need to do to make our denominators the same. And as we do more examples, you'll see that we're going to start timesing by other things. But again, guys, if you don't understand, please tell me what you don't understand, where you're getting confused. Unfortunately, I don't have time to re-explain everything. So if you give me a specific, I can help you. Otherwise, you're welcome to put your question on the chat or send a message to Yolanda or myself, and we can try and help you. But we need specifics.
Yeah, guys, we love you. Mela, we love you. And we want you to ask questions. But you need to understand when Teacher Sam says, now it's time for hands for questions, you need to press that reaction button there and find that hand and be like, yes, now you're going to answer my question. Or you can just put it on the chat. But you saying, I don't understand, Teacher Sam and I, we don't understand, where are you stuck?
Okay, guys, so I'm assuming you've all taken screenshots. We're going to jump to our brain break. Remember, this is sort of where we left off on Monday. We couldn't quite get our final answer. And so I'm hoping that someone has gotten an answer for me.
Yes. Let's go. So, okay, I don't even remember the answer. I tried to, I think I know the answer. Okay, but I'm not sure. But I love the chat. I mean, I love the joke that I'm legitimately taking a picture and putting it on my status because I love it so much. So that's what I'm gonna do, guys. So did you read the joke, my people? Oh wow, well done. Oh yeah, who got it first? I missed it because I talk a lot. It's Sotletelo. Sotletelo, well done. Sotletelo, please raise your hand so you can explain to the whole class how you got to that number. Well done. And I see some of you, like Fiona, also got it right. So Sotletelo, please raise your hand so you can explain to us, right? If an adult has helped you, surely you ask how did they get it, right? Because you were allowed to ask anyone. So raise your hand and explain. And also Fiona, raise your hand and explain. Whoever raises their hand first, they can explain. Mbali also got it right. Nia also got it right. Tingo got it right. Anyone who can explain to us, please raise your hand. But well done, my people, for asking. Y'all are loyal. Teacher Sam and I love you because you are loyal. You went and did your homework. So proud of you. Sizani, don't worry. So are we still waiting for someone to explain? If you guys don't want to explain, it's okay. Teacher Sam and I can just explain it. It's fine. Susanna, but you don't have to worry. So a brain break basically is just something that we do to have fun while everyone is stretching. While everyone, I want Tandoloet, please wake up and stretch. That would be very nice. If you could just wake up and just do this. Yes, thank you. Thank you. Just stretch. Stretch Tandoloet. Maybe you'll feel a little bit better. Do the stretching, okay? While we wait for someone to, guys, we don't have time. We're running out of time. So I hope that some of you are making a plan to come and talk to Teacher Sam and I. But well done to all of you, whether you just ask an adult or whether you find it by yourself. Teacher Sam and I, we give all you guys like applause. Well done, you did a great job. Yeah, Teacher Sam, should I explain or you can explain the break?
No, if you want to explain, I'm happy. I'm answering questions, so I'm more than happy if you want to.
Okay, so you'll help me if I'm getting confused. So I didn't write it down. So guys, if it's 20, if the tortoise, right, all added all together, they give you 24. What we do, which is something that you're gonna learn later, is that you add all of them. So if we count, if we say we have 2 plus 2 plus 2, we can say we have 6 tortoise, right? So you can put there 6x equals to 24. So now you can just take your calculator and say, well, what is 24 divided by 6? Because we need to get rid of the 6, right? So we can find what x is. So guys, if you don't understand this explanation, don't worry, because we're gonna get there. You guys are gonna do this after the learning of the fractions. You are actually going to learn algebra, okay? So we get a 4, right, when we divide by 6. So meaning that what I found is the fact that each tortoise is a 4 and a 4 plus another 4 plus another 4 plus another 4 plus another 4. That gives us 28, okay? Now that we know that that happens, yes, thank you, teacher Sarah, we can then actually label the second row. We can say, well, we know one tortoise equals to 4, so we can label that and say we have 4, 4, but I need to get to 24, right? That's where the maths 24 actually helps. But if you're someone like me, who is a little bit like, whoa, I'm still learning, then you're like, what can I multiply 4 with? That when I add 4, I actually get 24. So now you need to think a little. But because I'm an adult, I could actually just do something tricky that you guys don't know, because either you think in that way or you apply algebra, which is something that you're going to learn. So don't worry again. We can say 24, and then we take the 4 that is there. When it jumps to the other side, it has to be having a minus sign, because it gets a positive sign where it is. When it jumps an equal sign, it has to be a minus sign. So we minus 4 from 24, we get 20. Now we're sitting with a multiplication, 4 times that thing there that I love, because they cook it, it's a seafood, but whatever it is, okay? So you're saying 4 times x, because it's something that you don't know, right? We always replace something that we don't know with an x. So we're saying 4 times it by x equals to 20, right? Because we have already eliminated the 4. So now we need to divide again by a 4 to get our x. So we say 20 divided by 4, and we get 5. So we know that our little guy there that tastes nice is actually 5. So we come there to the third row and we put 5 and a 5, because there's 2 of them, right? So it means there in total we actually have 10. So we keep that in mind. But then now we need to arrive to 154. So I do the same thing. I say, well, I can take the sides to minus, because if it's positive, when it gets to the other side, it will be minus. So I take 154 minus 10, right? And the answer is 144. So, but I know that I have 4 fishes in total. You agree, my people? If we have 4 fishes in total and they're multiplying each other, we can say, well, we can have actually, I'm not sure if I should call it 2x times 2x. Will that work? Then I have 4x in total. Or that actually won't work. I'm still finding out. So teacher Sam can help me.
So
I
guys,
think
like
it
would have to be 4x squared. Yes.
Oh wow. My people, don't do it that way.
I mean, you definitely can. Like, absolutely.
Do you think that they actually do x squared in grade 8?
Probably not yet.
Already.
But once we learn about exponents, we'll be able to do x squared.
Oh, okay.
Like Yolanda says, guys, you've got 4 fishes here. But bear in mind, you've got 2 fishes times 2 fishes. So you want the same number that you're multiplying twice to then be able to add the 10 onto it. So if we go 12 times 12, we know that that is 144. And then if we add the 10, like Yolanda told us, we get 154. So that means one little fish is 6 and 6.
Yes. Guys, now we know. And then we know the nice thing, and we know the 2 tortoises, and that's how we get 52. Don't worry, you see, I also struggle. So there we go, my people. Well done. Well done, guys. Nice one.
So guys, what you do need to remember though is BODMAS. And like that's what Yolanda's been doing the entire time, is using BODMAS. So remember your multiplication first, 40, because 5 times 8 is 40. And then when you add 12, you get that 12. You get that answer that Yolanda just gave us of 52. All right, so BODMAS is very important. And this is essentially how you solve these brain breaks. So if you're new, have a look at how we did this, and this is how you need to go and work through these. And like Yolanda said, like as she was explaining, all of this stuff applies to so many sections of math. There's algebra, there's solving equations, there's exponents, there's order of operations. So yes, it seems like a fun thing, but it is so important to get these skills right. Alrighty, so if you want to take if you guys want to take a screenshot of this, by all means do so. Otherwise, we're going to have a look at some more examples. So hopefully those of you that are feeling a bit uncomfortable with fractions, you'll start to feel a little bit more comfortable as we do some more examples. Okay, Lydia, I see your hand. Do you have a question before I move on?
Ma'am, how did you get 6 versus 12?
Yes, so two fishes together is 12, which means one fish is 6. So if 2 fishes are 12, I can't draw a fish, that's a weird looking fish. So if 2 of my fishes all together is 12, that means each fish has to be 6, because 6 plus 6 is 12.
Okay, ma'am. Thanks.
Sure.
Well done, my people.
Jamila, question?
I wanted to ask, how did you get the 150 again? Because I don't understand there by the fishes.
Sorry, how did we get the what again? The 154?
The 154.
Okay, so we know that 2 of these lobsters, because 1 lobster is 5, 2 of them is 10. So we know that, let me just take all of this off quickly. So we know that we've got 10 plus something times the same value must give us 154. Now, if we already have 10, of this 154, I've already got 10. So that means I'm missing 144. So that's what Yolanda was saying earlier. If we say 154 minus 10, I get 144. And then I have to ask myself, what are the 2 same numbers I can times together to get that? And 12 times 12 is 144. So these 2 fishes together, when I multiply 12 and 12, I get 144. But then I still have to add the 10. And so 144 plus 10 is 154 then. Does that make a bit more sense?
Thank you.
Pleasure. Alrighty, guys, so let us have a look at some more examples. I'm just going to quickly go back to these 2 in case anyone wants to take a screenshot of those. And you forgot, but I'm not waiting for very long. I'm moving on. 1, 2, 3. Right. So let's have a look. So guys, the same thing happens when we subtract. Nothing is changing here. We find our LCD, we make the denominators the same, and then we subtract. So we're going to do that. Step number 1 is LCD. So I've got the denominators 8 and I've got the denominator 3. So let's list our multiples. I've got 8, 16, 24, 32. That was a little bit panicky, 40, and so I keep going. If I then list my multiples of 3, I've got 3, 6, 9, 12, 15, 18, 21, 24, and so I can keep going. So quickly on the chat, guys, which is my common number? Which is the smallest number common to both? Nice, someone nice, Lisa Kanya. Nice, guys, well done. So 24 is the smallest number that I find in both. So that is the smallest number that I can divide 8 and 3 into. And so that is my LCD. So my LCD now is 24. So I'll go back to my original question and I say, okay, what should I times 8 by to make it 24? Well, 8 times 3 gives me 24. But what I do to the bottom, I must do to the top. And so I must also multiply the 1 by 3. If I go to my second fraction, I need to ask myself, what should I times 3 by to make it 24? And if I times 3 by 8, I'll get 24. But what I do to the bottom, I must do to the top. So what I'm going to do is I'm just going to write this out so that you can clearly see what I'm doing over here. And so for me to make these denominators the same, I have to do a multiplication. So I'm now going to multiply the 1 over 8 by 3 over 3. and I'm going to multiply the 2 over 3 by 8 over 8. So if I look at my first multiplication, so this one over here, 1 times 3 is 3, 8 times 3 is 24. If I then look at my second multiplication, I've got a minus, 2 times 8 is 16, 3 times 8 is 24. And so now that I've got my common denominator, I can essentially now go and simplify. So I've got 3 minus 16 over 24. And guys, because we've done integers, we understand that we can get negative answers. And I'm just going to write this over here. 3 minus 16 is negative 13, all over my fraction, or rather of my all over my common denominator of 24. Now just remember, you always want to check if you can simplify. You always want to check if you can simplify your fraction. If you aren't sure, type it into your calculator. Your calculator will always give you the most simplified answer of your fraction. Now, 13 and 24, there's nothing I can divide into both of them. 13 is a prime number. So unless I could divide 24 by 13, I can't simplify that any further. And so that is my final answer. But always, this is just a reminder for us. We always need to check if we can simplify our answer. Sometimes you can, sometimes you can't. You do need to check though. All right, so you guys have been listening so nicely. I'm going to leave this up there so that you can see how we did A. I want you to try B for me. So remember, first step is find your LCD, then make your denominators the same, and then go and subtract. So I want you to try it for me. For now, put your answers in the chat, just label it B, and then I'll ask for some hands when I've given everyone a chance, but I don't want hands yet. No hands yet.
Sam, you're more than welcome. Just put your Samu, yes, sorry, Samu. Just put your answers on the chat for so long and we can see what you got. And of course, we cannot say the answer, but at least when we do corrections, we will know who has to do corrections. And it's always good to do corrections. So I hope you are writing on your books first and then giving us answers here. Okay. Okay, my people. Let's do that. Let's go. So far, I see different kinds of answers that has been proposed on the charts. Let's go. And remember that when...
No, carry on.
I was just saying that they should remember that we need to mark. So, and please call it B equal to and give an answer. Okay, my people on the charts. I see some of you are helping with the LCD. That's good. Hint, hint, everyone.
And guys, remember.
Sorry, teacher Sam, it's because I talk a lot. You can talk.
I was just going to say, remember, you'll probably have a fraction as an answer, and then you can double check if it can be simplified. So please just bear that in mind as you are doing your working out. Some of these answers are looking good so far. Remember, we always want to simplify. So Brian, that looks good, but remember, we want to simplify. Okay, I'm going to give you another minute and then I'm going to ask for hands. I don't want any hands yet. I will tell you when, but I'm just giving you another 60 or so seconds. Okay, I'm seeing some good answers. Just make sure you are 100% sure on the sign that you're using for your answers. Alrighty, so if anyone wants to raise their hand, now is the time to do it, to explain how you do B for us. Right, Nigel, do you want to explain for us?
Yeah, and the number B, we said 4/9 minus 2/3. And then we'll find our LCD. And our LCD is 9.
Good.
And then we're going to multiply them. We're going to multiply their one to both. And then we say 1/4. 1 time is 4 and 1 time is 9. It's 9.
Yeah.
And then we say 3 times 3, it's 9.
Good.
2 times 6. 2 times 3 is 6.
Good.
Then we are going to minus 6. 4 minus 6 over 9 is equal to 2/4. That is our final answer.
Okay, is it +2 or is it -2? What is 4 minus 6?
It's -2.
-2. Excellent. Well done. So guys, there is our final answer. Very, very nicely done. Very nicely explained. So our LCD here was 9, which meant that our second denominator needed to be made into 9. So we times them by 3. And I got 4/9 minus 6/9. And then I did my subtraction. Now, guys, what you need to remember is some of you, and I think Brian had put it on the chat, Brian had put in -4/18. And so you just use a different common denominator. That's not the end of the world. But what we need to do is to simplify. So someone asked in the chat now, how do we simplify? I'm about to explain it, so listen up. What we want to do is we want to see if I can divide both of these numbers by the same value. So here I can divide 4 by 2 and I can divide 18 by 2. And so I can simplify by doing that division. -4 divided by +2 is -2. And 18 divided by 2 is 9. And so I've simplified my answer to get exactly the same thing. So always double check if you can simplify. Always make sure that your signs are correct. Where a lot of people lose marks is for something silly like signs. And just, like I say, always make sure that your answer is in the simplest form. If you aren't sure, type it into your calculator. So I'm going to use this as our example. If I type -4/18 into my calculator and I push equals, it gives me -2/9. And so your calculator automatically simplifies it for you. So you can always double check yourself with a calculator. All right, guys, so what I'll do is I'll make that a touch smaller in case you need to screenshot both.